Yes.
I was like like a new technique. I don't know whether I'm going wrong over here, so I just wanted to discuss it with you.
Hmm.
Uh, like over here in the denominator, we can say it's 3 sin x plus 5 cos x.
Hmm.
So if we consider it to be in the trigonometric form, like if we consider a right angled triangle,
Hmm.
5 is a Pythagorean triplet.
Hmm.
So we can kind of write it as 3 sin x plus 4 cos x plus cos x. And now we can divide the entire denominator and numerator by 5. And after that, we will be getting a combined expression of 3 by 5 sin x plus 4 by 5 cos x plus cos x. And in
Hmm.
numerator, we will be getting 136 by 5 sin x. So
Hmm.
we can convert it to sine 37 degree sin x plus cos 37 degree cos x plus cos x. So now kind of simplify it into cos of 37 degree minus x. Like this, can we proceed? Plus cos x.
So I understood what you're trying to say. So your goal is to convert this 3 sin x plus 5 cos x into a singular expression of sine or cos, correct?
Yes, sir. No, say it's into cos because it is sine 37 degrees.
Yes, so rather than considering or forcing things here, which you are doing because you're considering 3 sin x plus 4 cos x,
Yes, sir.
which is a very good choice. But here it is 5 cos x, but it's fine. You don't need the degrees for it because 3 sin x plus 5 cos x can also be written in the same way, which you want to do 3 sin x plus 5 cos x. So 3 square is 9, 5 square is 24, it's root 34, right?
Oh yes, yes. I
So root 34 into 3 by root 34 sin x plus 5 by root 34 cos x.
yes,
And
sir.
now you can assign this as sine alpha and this is cos alpha. Or you can assign this as cos alpha and this is sine alpha. And this is basically root 34. I don't need a bracket. I can simply write sine of x plus alpha, where alpha is just a number, which is sine inverse of 5 by root 34.
Yes, sir. We can
So
do
you
it.
get a sine x by sine of x plus alpha. You get this expression. If you want that, you can do this like this.
Yeah, yes. I actually wanted to convert it in that form.
Yes, so this is how you convert. You simply divide by root over of a square plus b square, where a and b are your coefficients.
Okay. Sir.
Okay. Anyone else got the answer or proceeded in a certain way you would like to share?
So, like, can we arrive to the answer in this way? Like, is there any possibility?
Can you arrive to the answer? That's something I do not think is possible directly because sine of x by sine of x plus alpha. Well, again, you do have to break it. I think.
Okay, sir.
But yes, I think you can put y equals to x plus alpha, where x the numerator simply becomes then sine of I think itna y equals to x plus alpha would be sine of x minus alpha by sine x, and then you can break the numerator and divide by sine x because you have the sine x in the denominator. Then
Okay, sir.
okay, I guess you can try it, but okay, there's a better way. Okay, yes, Harsh.
Hello,
Yes, hello.
it's Harsh. I'm saying that I tried to proceed in a way like I broke 136 in 17 into 8, and then I took the 17 out of the integral as it was a constant, and I thought of breaking 8 as 3 plus 5 multiplied by sine x, and then is there any way possible that I can do it like taking the numerator as t and then differentiating it so that like 3 sine x plus 5 sine x, and in any way I can get that the denominator part, like I was thinking of getting like that.
Well, okay, okay. I get what you're trying to do here. So, well, your idea is correct. The execution is not.
Okay.
Okay, so yes, that is the idea. That is how you're going to do this question, but not exactly how you did it. That is not how you
Okay.
will do it, but the same idea will apply. I will discuss the solution in a bit. Yes, Madhur, can you raise your hand again? Harsh, you can lower your hand. Mathur, can you raise your hand again? You were raising hand. You are raising your hand right now, right? You can raise it again, and then we will proceed to the solution. Yes. Yes.
Hello, sir. Can you hear me?
Yes, I can hear you. Now you're audible.
Yes, sir. I just made a calculation mistake while putting the limits. I took cos 0 to be 0.
Okay.
Otherwise, I was proceeding by the same way you told, making it a combination of linear and its derivative
Mm-hmm.
with some constant alpha and beta. And then one side there will be only a constant left and
Correct.
dx integral that will be x. Other side there will be log of the denominator.
Correct.
Final answer. Then we have to just put the limits. So I just made a
Excellent.
mistake there.
It's fine. It's fine. Do not make the mistakes in exam hall, but here it's fine. But yes, that
Yes,
is
sir.
the idea. Well done. Okay. Okay. So
Yes, sir.
let's
Thank you.
discuss a solution. Yeah, you can lower your hand for now. Okay. Okay. So see, guys, the thing is, in this kind of questions, this 136 is not the issue. Okay. 136, keep it outside. Do not worry about this. This is there to confuse you. Even without this, the question would be the same. Okay. Question simply is sin x by 3 sin x plus 5 cos x dx. Work with smaller numbers. It's easier for our human brains to contemplate this, right? We are not computers to crunch numbers up like this. So now, what do we want to do? Our target is to write sin x like this. Some constant c1 into 3 sin x plus 5 cos x. You may ask why. Well, if I were to write this, okay, I will write another part here. But if I could write sin x like this, then this part would be in the numerator, and then whatever plus is there, it's fine. Using distributive law, I can make a whole new integral. I can make two different integrals, right? And in the first integral, you would see that 3 sin x plus 5 cos x would get cancelled in the numerator and the denominator, and you will be simply left with c1, which is a constant. c1 dx rahega bas, correct? That is the motivation. Second में क्या होगा? C2 whole into derivative of 3 sin x plus 5 cos x, which is 3 cos x minus 5 sin x, right? Now, what happens here? 3 cos x minus 5 sin x में, what is the motivation for this part? Well, जो other integral बनेगा, उसमें you see, if you substitute 3 sin x plus 5 cos x as t, then this expression 3 cos x minus 5 sin x dx, which will be in the numerator, will simply act as a dt, correct? Or substitution के बाद your integral would be dt by t, because this was t and this is dt. This is the derivative simply. That is what we are doing here. And वो integral directly log of t बन जाएगा, जहाँ पे t you can back substitute. This is the motivation for writing sin x as a linear combination. जब मैं बोलूँ दो factors का, उसका मतलब होता है a constant c1 into the first factor plus a constant c2 into the second factor. All that remains is to find this c1 and c2. How do you do that? Well, you simply write this as sin x equals to collect all the sin x के terms. तो sin x के क्या terms होंगे? 3c1 और एक यहाँ पे क्या है? minus 5c2, correct? And then collect all the cos x terms. Cos x का क्या है? Cos x का है 5c1 and then I think plus 3c2. So compare the coefficients. You see that 3c1 minus 5c2 is 1, equation number 1. 5c1 plus 3c2 is equals to 0, equation number 2. Simply find out from this second equation that c2 is equals to kitna? Minus 5 by 3 c1. Put this in the first equation and you should get 3c1 minus 5 into minus 5 by 3 c1 is equals to 1. This would mean 3c1 plus 25 by 3 c1 is equals to 1. 34 by 3 c1, and surely you should be seeing how this 34 basically comes up, which we randomly did. So there was, after all, a significance of this 34, which is root over 5 square plus 3 square, right? Which suggests that your method is also fine and it could be done. Like we said, x plus alpha equals to y karke. Okay, so this means C1 is 3 by 34, correct? Now, once you have 3 by 34, we can also find out C2, right? What would be C2 then? Well, C2 would be simply, as we talked, minus 5 by 3 into 3 by 34, which is minus 5 by 34. Now we have C1 and C2, and we can write this. So our integral I simply becomes 136 times 0 to pi by 4. The numerator becomes C1, which is, I would simply write it as C1 sin x plus cos x plus C2, actually 3 sin x plus 5 cos x, sorry. And this would be 3 cos x minus 5 sin x, right? Divided by 3 sin x plus 5 cos x. Okay. Okay, now break this into two different integrals. First integral, you will simply have 0 to pi by 4 c1 dx. Second integral, you should simply have 136 c2. And then integral of 0 to pi by 4. This 3 cos x minus 5 sin x dx can simply be written as b of 3 sin x plus 5 cos x, correct? And in the denominator, you simply have 3 sin x plus 5 cos x. Okay. First one is 136 c1. Second one is 136 c2 into ln of into pi by 4. This one obviously. And second one is ln of 3 sin x plus 5 cos x. And this integral goes from pi by 4 to 0. Let us try and do this. 136 common. So C1 pi by 4. So C1 pi by 4 plus C2. And now let's evaluate this at pi by 4. So at pi by 4, you can see this is 3 plus 5 by root 2, which is 8 by root 2, which is only 4 into 2 by root 2, which is 4 root 2, correct? Minus, when you put 0, it simply becomes log of 3 into 0 plus 5 into 1, which is ln of 5. Put the values of C1 and C2. So what will you get? You would simply get 136 into pi by 4 into C1 was, I think, 3 by 34 plus 136 into 5 minus 5 by 34 actually, minus 5 by 34 into ln of 4 root 2 by 5. So I think this is what you're going to get, and you can simplify it further, it's fine. But yeah, this is going to be your final answer. Hope that's clear to everyone how it was done. If there are any doubts, let me know. Let me know if there are any doubts. Text is too big. Acha, the screen was smaller, right? How can I do that? I guess I can decrease the thickness. Yes, I'll decrease the thickness and try to write smaller maybe. I could do that, yeah. I could try that. Okay, now anyone? Doubts on this whole section? Or in the linear combination part, whichever. I'll give you 2 minutes to think about the problem and the solution. We will discuss the doubts. Raise your hands after 2 minutes. Whoever has doubts. Be prepared with the doubts. So this is the 2 minutes where you have to think. Okay, everyone else, if you have no doubt, just write like surely we did. Like absolutely no doubts. Yes, no. Control and minus would also make the screen smaller for me as well, not only for you, right? So I would like to see it as big as it is, but I would like you to see it smaller. That's the issue. And here, since I'm not in Streamlabs, where I can share my screen and adjust it for you, it's the Class Plus web portal. So it becomes difficult for me because they do not really have features like that. Harsh and Madhu, right? So I'll come one by one. Okay, Harsh only, I guess. Yes, Harsh.
Yes, Bhaiya, I was asking that there is no such doubt in this question, but my general doubt is that how we will get this kind of approach in exams, means just by seeing the question, how we'll be able to get this clicked? Like,
Okay. Usually, जब denominator में you have trigonometric functions, or if you have linear functions.
hmm?
and denominator में you have something which could be represented as the derivative. So for example, I can give you a very easy way of saying this. So if you have something like this, okay, let's say integral of, I will just give us random example, px square plus qx plus r and ax square plus bx plus c. Okay, let's say you
Yes.
have this. My intuitions tell me I maybe could be able to write this as some combination of ax square plus bx plus c k1 plus k2 whole into 2ax plus b. I might be able to do this, correct?
Yes, भैया.
Which means पहला वाला कट ऑफ हो जाएगा, you will simply have a k1. Second वाला तो derivative है, which means again log of ax square plus bx plus c. So if you have something which could be represented, there is a slight chance it might be represented as the derivative of the denominator, then you can proceed with this method. Where in trigonometric functions, it usually is the case if these are linear functions, right? Not tan square x, sec square x, cos square x like that. There is a chance that the 3 sin x plus 5 cos x का derivative भी sin और cos में ही आएगा, and we simply have a sin x expression. So we know that, okay, there is some way we can write it. Okay.
Yes, भैया.
Okay, clear about this? So, well, obviously, it would require you to do a lot of practice as well. But yeah, these things come with practice. Okay. Chalo.
Yes, sir. We can write it as log 1 by log.
Log 1 by?
No, no. But if we write by log 1 by log x, it automatically becomes 0. Then.
I do not get you. I did not get you. A log 1 by log x, you
No,
said?
it's log 1 minus x.
Yes, log of 1 minus x, yes.
No, I was thinking differently.
It's fine. Okay.
It's not working.
Yes, coming to Vijitakshar. 1 second. Yes.
यस सर.
Yes. Say.
सर मतलब अगर ln 1 माइनस एक्स की पावर अल्फा लेके डिवाइड बाई एक्स, मतलब एक नया फंक्शन हम डिफाइन करेंगे जिसका अल्फा एक नया वेरिएबल होगा. 1 माइनस
Function क्या होगा?
ln.
So let us say f of alpha, right? Alpha is the parameter.
हाँ हाँ.
Okay. Yeah. फिर क्या लिखूं?
0 to 1
0 to 1.
ln 1 माइनस
Mm-hmm. Alpha x.
एक्स की पावर अल्फा.
अच्छा. Wouldn't alpha x be a bit easier?
हाँ, डिवाइड बाय एक्स एक्स. अब आप डिफरेंशिएट करेंगे.
अल्फा के रिस्पेक्ट में, राइट?
हाँ हाँ.
करने के बाद नीचे आ गया x इंटू 1 माइनस एक्स टू द पावर अल्फा, ऊपर आ गया, ऊपर क्या आएगा?
माइनस अल्फा इंटू एक्स की पावर अल्फा माइनस 1. तो
You are differentiating with respect to alpha and not with respect to x.
अल्फा एक्स लेना पड़ेगा तब शायद हो जाएगा अच्छे से. हाँ, तब एक्स कैंसिल हो जाएगा. हाँ, अल्फा एक्स.
Let's take a new approach. तब g of alpha equals to 0 to 1 ln of 1 minus x alpha by x. Okay, अब बताओ g dash alpha क्या होगा?
1 by x.
0 to 1 फिर
1 by x minus alpha.
x whole into 1 minus x alpha और फिर ऊपर
x आ जाएगा माइनस
x.
नीचे x कट जाएगा.
तो minus 0 to 1 dx by 1 minus alpha x, which is
अब वापस से मतलब
evaluate कर लो ना इसको.
ln 1 minus x
ln of 1 minus alpha x नीचे एक डिवाइड हो जाएगा माइनस अल्फा से.
हाँ, तो इधर लिमिट पुट कर देंगे अभी.
ठीक है, तो पुट करते हैं. कितना आ रहा है? x का लिमिट 1 पुट करेंगे तो ये आ जाएगा ln of 1 minus alpha.
हाँ,
ये आ रहा है बाई अल्फा. Do you see you arrived at the same result? अब हम इंटीग्रेट करेंगे तो एक्चुअल में हम ln of 1 minus x by x को ही कर रहे हैं वापस.
हाँ, और
We just looped back there.
कुछ गड़बड़ कर रहा हूँ मतलब.
नहीं, ये अगर फंक्शन हम ऐसा लेते हैं तो दिस स्टेप्स आर करेक्ट, बट अल्टीमेटली जब हम पहुंचेंगे यहाँ पे वी हैव अराइव्ड एट द एग्जैक्ट सेम फंक्शन वी टुक. So this method or this method, both of these methods, in this case, seems not so useful. Rather, क्या कर सकते हैं हम? पहले तो इसको देखो. Yes, surely. Acha, you cannot speak at once, both of you, I guess. Yes, yes, surely. I'll come back to you, Jidakshar. Just give me a minute. Yes, surely. You raised your hand, right? Okay, it's fine then. Yes, tell me. Did you have
Uh,
an approach?
yes, sir. Sir, I was thinking of using series expansion. Can we use
Hmm.
that? Like
Definitely.
ln 1 minus x, we can write it as minus x square by 2 minus x cube by 3 minus till infinity and
Hmm.
divided by x, and
Hmm.
then we can basically cancel out all the x's,
Hmm.
and we can get a clear value of this integral.
Hmm. Which is
N is equal to 1 till infinity,
okay. I'll write it as the summation n equals to 1 to infinity, and then
and then it will be minus 1 minus x by 2, like that it will keep on.
hmm.
Yes, sir, like that. Can we do it in this way? And then we can use um, maybe yeah, we can use UV rule.
We can simply do this.
We can use UV rule like
You can simply take everything which is not a part of the integration outside, and this is the integration of the summations, which is the same as summation of integrations, because integrations can be written as summations of different integrations can be written as summations as well.
yes, sir.
So this would mean minus n equals to 1 to infinity 1 by n squared. Why? Because 0 to 1 x to the power n minus 1 dx is also 1 by n.
Yes, sir.
And this might be something you have seen in a lot of places, and I think a lot of you have seen it in coaching materials as well, online as well.
Yes, sir.
Some of the squares of the reciprocals of the first, not first, like all the natural numbers is nothing but pi square by 6.
Yes, sir. Pi
This,
square 6, yeah.
yes, this is called the famous Basel's problem. So what happened is Basel was a mathematician who proposed this problem back in the 1700th century. So he said that, okay, I want to find out the sum of the squares of these natural numbers. I cannot find a way to do so, but I would like to find this. Other great mathematicians commented that, okay, this is definitely greater than 1 as a joke. Some mathematicians even said that, okay, it's greater than 1.5 and less than 2. What next? Like, how do we find out the value? Finally, in 1764, Euler proposed a solution which was finally given recognition. Ki, okay, this is how we do it. He proposed a solution using Hadamard factorization of sin x and equating the power series of sin x, which ultimately gives you the pi square by 6 expression, which is a topic for another day and not at least in this course. Those are reserved for ISICMI courses. But yes, that is how you do this, and you can simply leave the answer here. So if you do not know the value, but yes, there is one other way you can exactly use the series expansion, but in a much more known way. So if you do not know the expansion of log of 1 by 1 minus x by x, you can rather use the King's property and you can write it as ln of x by 1 minus x dx. And now notice that x belongs to 0 comma 1, and also 1 by 1 minus x therefore can be written as 1 plus x square plus x cube and so on. Because this is valid, as x belongs to 0 to 1, the common ratio x is within the limits for this infinite geometric sum to converge, which means I can write 0 to 1 summation n equals to 0 to infinity x to the power n into ln of x dx. Correct? This would mean I can now again swap the summations and integrals and write it as n equals to 0 to infinity 0 to 1 x to the power n ln of x dx. And again summation n equals to 0 to infinity. This thing is nothing but 1 by n plus 1 whole square. No dx obviously. And this is again the same as 1 by 1 square and stuff, which is there would be a minus obviously. Pi square by 6 minus. Now this much is clear to everyone? How we arrived at this result? Just write in the chat if it's clear. And Chitakshar, if you are, sorry for interrupting you there. If you have something to say, please raise your hand. We can continue discussing what we were discussing. And also, we'll end the session very soon now, and we'll continue maybe next week. I'll schedule another session very soon. So there would be it would be some time before you get the theory portion because it's already being processed. So anyway, that is why I'm trying to compensate a little bit of time for the live sessions. Yes, Madhur.
Sir, could you please explain the 1 by 1 minus x part once again?
Yes, so stay with me. Since x belongs to 0 to 1, correct? It's in the interval. Now, if you remember, in an infinite GP, the infinite geometric progression sum only converges if your common ratio is between -1 to +1, correct?
Yes, sir.
Right. Now, what happens here, if you see it from the other way around, if you see it like this, 1 plus x square plus x cube and all the way up to infinity, it's an infinite GP with first term 1 and common ratio x.
Yes, sir. Okay.
You know the answer is a by 1 minus r, just put it in the left hand side.
Yes, sir.
We did it the other way around. We simply introduced this as an infinite series rather than evaluating the infinite series. Okay?
Yes. Yes, sir.
Okay. Chalo. Okay, one last problem before finishing the session. 0 to 1, x to the power m, ln x to the power n dx. Answer to this question, where m and n are, let's say, positive integers.
हेलो सर.
Yes, hello.
सर वो जो आपने प्रॉब्लम दी ln(q1 - x) वाला, उसमें सर अगर 1 - x को e पर y पुट करें तो मतलब -dx इक्वल्स टू e पर y dy आ जाएगा. तो मतलब पूरा प्रॉब्लम जो है ना, जब e पर y पुट करके सब्स्टिट्यूट करेंगे, मतलब पूरा अलजेब्रा में चेंज हो जाता है ln से पूरा प्रॉब्लम. तो वैसे हो सकता है.
e भी आ जाएगा ना, नीचे x आ जाएगा ना कि 1 माइनस e टू द पावर y.
हाँ, लेकिन 1 - x इक्वल्स टू e पर y, तो 1 - x इक्वल्स टू x आ जाएगा. नीचे भी 1 - x आ जाएगा, ऊपर भी e पर y आ जाएगा, क्योंकि अंदर e पर ln के अंदर e पर y
देखो,
घुस जाएगा. तो
I'll do the substitution. ठीक है, 1 माइनस x e टू द पावर y, राइट?
हाँ
हाँ, तो करते हैं उसको. तो x मतलब x बेसिकली है 1 माइनस e टू द पावर y. ओके,
हाँ
तो ये बन गया मेरा क्या, ln क्यूब ऑफ e टू द पावर y, विच इज सिंपली y क्यूब, है ना?
हाँ.
ओके, x क्या बन गया, 1 माइनस e टू द पावर y. dx क्या बन गया, माइनस e टू द पावर y dy. लिमिट्स क्या बन गए मेरे, लिमिट्स बन जाएंगे आई थिंक y कितना है, ln ऑफ 1 माइनस x बेसिकली.
हाँ
तो x अगर 0 है तो ये बन जाएगा 0,
हाँ.
और x अगर 1 है तो ये बन जाएगा माइनस इन्फिनिटी.
हम्म,
ओके, सो यू सी यू हैव y क्यूब, यू हैव e टू द पावर माइनस y दोनों.
हाँ, बाईपार्ट्स लगा सकते हैं इधर.
हाँ, पहले तो एक काम कर लो, पहले y को माइनस y बनाओ, y को माइनस z करो. ठीक है, तो ये बन जाएगा 0 से इन्फिनिटी, ये बन जाएगा माइनस z क्यूब इंटू माइनस e टू द पावर माइनस z डिवाइडेड बाई 1 माइनस e टू द पावर माइनस z, और dy भी बन जाएगा माइनस dz. लेट मी डू इट हेयर. तो ये जो इंटीग्रल है, दिस वुड सिंपली 3 माइनस है, तीनों माइनस ही बनेंगे अल्टीमेटली. माइनस 0 टू इन्फिनिटी e टू द पावर माइनस z क्यूब बाई 1 माइनस e टू द पावर माइनस z dz, करेक्ट? ये बन रहा है ना अल्टीमेटली. कैन यू राइट e टू द पावर माइनस z बाई 1 माइनस e टू द पावर माइनस z एज अ इनफाइनाइट सीरीज?
हाँ, लिख सकते हैं कॉमन रेशियो e पर z.
e पावर माइनस z.
हाँ
और फर्स्ट टर्म भी e पावर माइनस z.
हाँ, तो कॉमन रेशियो e पर
तो n इक्वल्स टू 1 टू इन्फिनिटी e टू द पावर माइनस nz, है ना? लिख सकते हैं ऐसे इसको, n2 z क्यूब. क्या आ जाएगा, ये गामा फंक्शन है. ओके,
गामा फंक्शन है.
तो n इक्वल्स टू 1 टू इन्फिनिटी z क्यूब मतलब गामा 4 मतलब 3 फैक्टोरियल डिवाइडेड बाई z टू द पावर 4. आंसर क्या आ गया, -6 बाई z टू द पावर 4 का समेशन, z नहीं n टू द पावर क्या है ये? n to the power 4 होगा obviously, sorry. Summation of n to the power 4, which is basically saying -6 zeta of, okay, which is कितना? The answer would be -6 into pi to the power 4 by 90. Answer क्या है? Minus pi to the power 4 by 15. ये होगा answer. Very nice, well done, very well done. Okay, any idea about this one? कोई मुझे कॉम्प्लेक्स वे नहीं बताएगा, मुझे सबसे इजीएस्ट वे चाहिए इस प्रॉब्लम का, क्योंकि मैं जब करूंगा इट वुड सीम लाइक द इजीएस्ट वे पॉसिबल, तो वो वही मुझे चाहिए. एनीवन? Sorry that I don't have much time to give to you all, but take a minute, think about this. For any integers m and positive integers m and n, we want to find out the value of x to the power m and into ln x whole to the power n dx. Are you sure, Libby?
Sir, I don't know whether it is the simplest way or not, but again, I have like taken ln x to be k.
K.
ln x as k.
Okay, k. Well, k is a very weird choice because it is usually a constant. Also, okay, I think you should take it as minus k, but I think you're going in the right direction. Okay, after that, say.
And then, sir, it's dx by x is equal to k dk. I mean, k dk over here. And then I'm getting a value like if I basically bring x in terms of k, then I'm getting e to the power k into m plus 1 k to the power n plus 1 dk. And again here I'm getting the choice of expanding e to the power k m plus 1. So here we can kind of apply the series expansion and then we can arrive at the answer.
One second. What is the term we are applying the series expansion to?
K into m plus 1.
K into 1?
M plus 1.
Okay, k whole into m plus 1?
Yes, sir.
Yes, and the limits are from for k are from?
0 to 1.
0 to 1, okay.
I guess. And we need to... so this is the limit and over here we need to again multiply it with k to the power n plus 1. Like with this...
By the way, you substituted k, so the limit should not be 0 to 1, right?
Yes, sir. I was thinking like that only.
Yes, so it should be minus infinity to 0.
Yes.
Yes, but now you cannot do series expansion. Why? Because, well, infinity wale terms aa jayenge, x to the power k whole into m plus 1 and stuff like that, and the limit is infinity. Which is why you should need something like this. Because see, जब infinity है, तो limit extends to infinity, e to the power x तो infinity होता है. Which is why we cannot apply series expansion where things go to infinity.
Okay, sir.
Okay, so okay, just see this question. What we can do is this. Think of the question like this. Make a function f of a, where a is a variable as well, and write this integral. This function is this integral basically, whose value we all know to be 1 by a plus 1. Now, just think, if we were to differentiate f of a, which is a plus 1, f of a is equals to 1 by a plus 1, right? If you differentiate it once, what will you get? F dash a equals to minus 1 by a plus 1 whole square. If you differentiate it again, what will you get? 1 by, so it should basically be 2 by a plus 1 whole cube. Correct. Differentiate it thrice, you should get minus 3 by a plus 1 whole to the power 4. Do you see the pattern? So differentiate it n times, you should get minus 1 whole to the power n into, so 3 के लिए 3, so n के लिए n, नीचे a plus 1 to the power n plus 1. That much is clear, correct? Therefore, this is n factorial, by the way, and not 3, because I think we differentiated this and we got 3 factorial here. Yeah, so n factorial. So we basically get this as the nth derivative of a plus 1 by a plus 1. Now come back to the problem. We also had f of a as this. F of a is 0 to 1 x to the power a dx. Differentiating once should give you Inside the integral, you're differentiating with respect to a, which means this is simply x to the power a log x, correct? Differentiate again, you would get x to the power a into log square x. Similarly, differentiate m times, 1 second, yes, Jitakshar? N times to get 0 to 1 x to the power a into ln x to the power n dx. Now these two expressions are equal, therefore put the value of a as m. You can simply write 0 to 1 x to the power m ln x to the power n dx is nothing but minus 1 whole to the power n factorial by m plus 1 whole to the power n plus 1. Yes,
हेलो सर।
yes.
सर मैंने सोचा ऐसे मतलब अगर हमने एक्स की पावर एम को फर्स्ट फंक्शन और एल एन एक्स को पावर एन को सेकंड फंक्शन लिया, तो जब हमने एक्स की पावर एम का इंटीग्रेशन करेंगे तब एक्स की पावर एम प्लस वन बाई एम प्लस वन और इधर एल एन एक्स का टर्म ऐसा ही रहेगा, लेकिन जब इधर 0 to 1 का लिमिट पुट करेंगे तो ये टर्म पूरा 0 ही हो जाएगा। तो मतलब हमें बस वही टर्म चाहिए, मतलब जो कि अंदर रहे, मतलब इंटीग्रेशन के अंदर रहे, मतलब एक्स की पावर एम प्लस वन बाई एम प्लस वन और इनटू इसका डिफरेंशिएशन, मतलब वही पार्ट चाहिए हमें सबका। तो ये वाला टर्म 0 हो जाएगा जो बाई पार्ट्स में आता है, वो वाला टर्म पूरा की लिमिट लिमिट हो जाएगा 1 पे एल एन 0 हो जाएगा।
ओके,
तो हमें बस जो सेकंड पार्ट है वो ही चाहिए। तब जो एक्स का टर्म है ना वो घटता घटता जाएगा, मतलब एल एन एल एन के पावर जो एन है वो घटता घटता जाएगा और एक्स की पावर एम बढ़ता बढ़ता जाएगा, मतलब पूरा जो ये टर्म है ना वो एक लीनियर पूरा टर्म में बढ़ता जाएगा एकदम लास्ट पे जाके, मतलब मतलब
No,
करेंगे।
correct, correct. This is correct. This is also one way to do it. Basically, आपको ये reduce करना है. You want to do
हाँ।
y parts और इस वाले power को बढ़ाते जाओ, इस वाले power को घटाते जाओ. So yeah, this is one way to use the reduction formula. That is correct. That is not an issue. So वो भी हम कर सकते हैं, but you have to figure out कि pattern क्या होगा. ठीक है, तो वी हैव टू सिंपली डू दैट, वो भी चलेगा। और आई होप कि ये मेथड समझ में आया होगा, हाउ वी आर डिफरेंशिएटिंग एन टाइम्स ऑन बोथ साइड्स। पहले बार जब हम डिफरेंशिएट कर रहे हैं इट इज रिस्पेक्ट टू ए इनसाइड द इंटीग्रल व्हिच इज व्हाई वी आर गेटिंग ln x, क्योंकि ए टू द पावर एक्स का डिफरेंशिएशन तो होता है ए टू द पावर एक्स इनटू ln a। तो यहाँ पे वही केस हो रहा है, बट डिफरेंस ये है कि ए है वेरिएबल, एक्स है कांस्टेंट। सो एवरी टाइम यू डिफरेंशिएट यू गेट एक्स टू द पावर ए ln x। फिर से करो, एक्स टू द पावर इंटू ln x वापस एक आ गया जो कि ln स्क्वायर एक्स बना देगा। n टाइम्स करो तो ये आ जाएगा, n वाले n ln x मल्टीप्लाई हो जाएंगे। बट एफ ए का nth डिफरेंशिएशन का एक और एक्सप्रेशन हमने निकाला, क्योंकि वी ऑलरेडी नो द वैल्यू ऑफ दिस इंटीग्रल व्हिच इज 1 बाई ए प्लस 1, जिसका पैटर्न से हमने निकाला कि दिस इज -1 होल टू द पावर n इंटू n फैक्टोरियल बाई ए प्लस 1 होल टू द पावर n प्लस 1। सो नाउ सिंपली f ऑफ m का वैल्यू एट द nth डिफरेंशिएशन इक्वेट कर दो इनटू इन दिस टू रिप्रेजेंटेशंस। We simply get the answer x to the power m and n x to the power n is -1 to the power n into n factorial by m plus 1 n to the power n plus 1. Another method, which is a preferred method as well, is proposed by Shorolipi, where rather than taking ln x equals to k, you should take ln x equals to minus k, or whichever variable you think is better. This is what you should take, because that is going to transform this into a beta function. कैसे? ये सिंपली क्या बन जाएगा, 0 to 1 x to the power a ln x की पावर b मान लो dx, a और b से करते हैं। इसमें सिंपली ln x को ले लो माइनस टी, तो x बन जाएगा e टू द पावर माइनस टी। नाउ इंटीग्रल देखो, ln x है माइनस टी, तो t इज बेसिकली माइनस ऑफ ln x, राइट? नाउ ln ऑफ 0 इज माइनस इन्फिनिटी, ये बन गया इन्फिनिटी। ln ऑफ 1 इज 0, दिस इज 0। x is e to the power minus t, so this is e to the power minus ta. ln x is minus t, so this is -1 whole to the power b into t to the power b, and dx is e to the power minus t dt and -1 again. This -1 goes into the integral to make it 0 to infinity. -1 whole to the power b is outside. You simply have e to the power minus at minus t into t to the power b dt. This should remind you of the gamma function, which is 0 to infinity. e to the power minus t कॉमन ले लो, a plus 1 आ जाएगा, and this is t to the power b dt. This is the gamma function, which means -1 whole to the power b t to the power b है, which means gamma of b plus 1 divided by जो कोफिशिएंट है, अगर माइनस टी के साथ कोई कोफिशिएंट रहता है, we simply divide that power of that coefficient raised to the power of gamma, like this. So whatever gamma is this value, we raise simply divide by the coefficient in e to the power minus t, if there is any, raised to the power of the same value inside the gamma. So just put the value of gamma b plus 1. This would become b factorial by a plus 1 whole to the power b plus 1. So in short, yes, this method also works just as fine. So we basically saw 3 methods for doing this. Great. Okay, it's fine. Tell me what approach you use. So someone open your mic. Like, it can't be this quiet.
Yeah, it is just by luck I got this answer, but in actual, my solution, I was not able to solve it completely. It
No,
was
no, it's
random.
fine. It's fine. Tell me how your luck helped you. That is okay.
I took cos cube x plus sine cube x like t. It was just a random guess and it got correct by chance. So I took it as t and then started doing something. But finally, I was not able to reach there.
Okay. So t as cos cube x plus sine cube x.
Thinking that I will get t square something at the bottom and I will try to evaluate the upper part in terms of dt something. But
Mhm.
but I got confused doing that. So
Okay. 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 So see, in this kind of questions, what happens? You see this cos square, sine square things, right? Always
yes,
try to divide by the highest power of cos square. Which means, what is the highest power of cos square in numerator or denominator?
cos square highest power
Cos is like cos x is highest power.
cube 3.
No, 6. Cos x cube, which is power
Oh,
2, which
yes,
is 6.
yes, 6. Oh,
It's an
sorry.
observation, okay? So what we'll
Yes,
do, we'll simply divide by cos to the power 6. Now, numerator में when we divide by cos to the power 6, what happens इसमें? ये बन जाएगा sin square x, एक cos square x तो cut off हो गया. It basically got cancelled.
yes.
Now we have another cos square x with the sin square x, and now again we have another 1 by cos square x, which is nothing but the sec square x.
Okay.
Okay, and now in the denominator we have to do the same thing. So cos to the power 6x will go inside the perfect square क्योंकि वो बन जाएगा cos cube x, and then we'll divide each of these terms. The first term will become 1 and the second term will become tan cube x. Correct? Which is how the integral simply becomes tan square x sec square x dx by 1 plus tan cube x. Simply multiply and divide by 3 for style points, because we are not really going to substitute tan x. We are rather going to do something else. Okay, Harsh, you can mute yourself. Okay. Yes, Aris. Yes, Kshitij. Divide by cos to the power 6x. Correct. So initially I got two ideas. First idea I thought of expanding the series, and second idea I thought of divided by cos to the power 6x. So it seems your second idea was on point. Or in any of this kind of questions, we divide by the highest power of cos, transform everything to tan. Okay, transform everything to tan or sec. That is the idea. Tan square and sec square work very well in integrals. You can see how. यहाँ पे you can simply substitute t is equals to, okay, let's take u, because Harsh earlier already made a substitution using t. So let's take this as our u. Okay. Now what happens if this is u, then du कितना होगा? Du would be, using chain rule, 3 tan square x, and then the differentiation of tan x sec square x dx. Does it match with our numerator? It does. Therefore, our integral is nothing. Now, 1 by 3 is outside. The limits are going to be 1 to 2 by putting 0 and pi by 4 respectively. What happens here? This becomes du and this becomes u square. So therefore, 1 by 3 integration is minus 1 by u, but we can simply write like this. And this would become 1 by 3 into 1 minus 1 by 2, which is 1 by 6. Therefore, we have the correct answer. If you do not have anything to say, Madhur, you can.
Sir, can you hear me?
Yeah, I can hear you now. Yes.
We can apply the odd even property, like integral minus a to a f x becomes integral 0 to a f of x plus f of minus x.
Mm-hmm.
So then the integral becomes if we do this, it becomes cos alpha x into 1 plus 3x over 1 plus 3x, which gets cancelled.
Mm-hmm.
So then we get sine alpha x as the final integral by alpha, sine alpha x by alpha,
Mm-hmm.
integral 0 to 1. Then I am not getting it. If we put the value, I get sine alpha by alpha is equal to 2 pi. 2 by pi. So that I am not getting.
Trust me, you are getting it. You're just not thinking. You got everything correct, and you are at the very last step, which is literally the answer. So just think and tell me what is alpha. Just think. Trust me when I say that you can do it, which means you can do it. Tell me what is
Okay.
the answer.
Excuse me, sir, your voice was not audible
Yes,
previously.
just tell me what alpha is. Think about the last equation you told me, and from that you can directly tell me what alpha is.
Okay.
Sine alpha by alpha is equals to 2 by pi. What is alpha?
Okay, alpha is pi by 2 then.
Correct, right?
Yes,
So,
yes.
so let's. You don't always have to solve for it. Yes, pi by 2. You don't always have to solve for it. You can simply write C from observation. So yeah, you can simply apply this as 0 to 1 cos of alpha x by 1 plus 3 to the power x plus cos of minus alpha x by 1 plus 3 to the power minus x dx equals to 2 by pi. Now, if you do this, cos of minus alpha x is cos of alpha x only, and if you do this, 1 plus 3 to the power x will get cancelled because this term, the second term, will have a 3 to the power x in the numerator. So, yeah, this would become 0 to 1 cos of alpha x dx, which is 2 by pi, or in other words, this will simply become sine alpha by alpha, which is 2 by pi. Or this would mean alpha is pi by 2 just from observation. Notice that it is not the only value because we have not proved it yet, which is not required since you are giving joint entrance examination and not a subjective exam, correct?